All right, so we've talked about the X-ray circuit and the X-ray tube, the different components. Now let's talk about X-ray emission. In particular, let's talk about mass and X-ray intensity. So we know from previous courses that mass helps directly control the number of electrons we're working with and pretty much the number of X-rays we'll end up getting. So X-ray intensity can also be described as the number of X-rays we'll get in the useful beam, meaning that beam that shoots straight out through the window and down toward the patient and the IR. Intensity is directly proportional to mass, so basically if we double mass, then we're going to be doubling the number of X-rays we should get. This is straight from your textbook and it shows you kind of that direct relationship. Intensity 1 over intensity 2 is equal to mass 1 over mass 2. So when something doubles on this side, it's going to double on that side. On the other hand, we have kVp. Now, it also somewhat affects X-ray intensity as well, and it's also directly proportional. The difference here, though, is that it is exponentially related. So basically, let's pretend that we're going to use this exponent right here, number 2. And let's say that we're going to have 3 times 2. So 3 times 2. So 3 would be doubled and we'd get 6. And that's when we're talking basically about mass. Now, if we're talking about exponents here, we're talking again about an exponent, which they show you here in the formula. And that would be 3 squared, which means we're getting a value of 9. So basically, when we say exponentially related, all we're saying is that it doesn't just double, it increases exponentially. So this is why when we talk about increasing kVp to alter contrast or dose, we only talk about 15% increases, definitely not doubling, because small increases have an exponential effect. And recall, if we're just trying to mess maybe a little bit with contrast or dose, then a best practice is to increase kVp by 15%, and at the same time, we decrease our mass to keep that dose down. So how about distance and X-ray intensity? Well, distance, again, as we can see here, has an exponential effect, right? So that means the inverse square law, it's that square right there, is that the more distance we get, the less X-ray intensity we have, and they're exponentially related. So if we double our distance from our destination, then we decrease our intensity by 4, for example, let's say. So intensity is inversely proportional to distance. Okay, so how about filtration? We talked about this a little bit when we talked about the X-ray emission spectrum. Remember, filtration, not only it reduces the overall number of X-rays we're getting, but it increases the overall energy of our X-rays. So it stops those low quality X-rays from reaching the body, and there's usually about 1 to 5 millimeters of aluminum or aluminum equivalent in our X-ray system there. And that's what we see here. Straight from your textbook here, we see we have about 0.5 inherent millimeters of shielding. Then they add about 1 millimeter of aluminum there. The mirror acts as another millimeter. And so overall, we might have around 2.5 millimeters of inherent filtration. Well, inherent and added. So total filtration. Sorry about that. All right, and this just goes through the different kinds of filtration, inherent or, again, added, to equal total filtration. And the last thing I'll introduce here is the concept of attenuation. So as X-ray beam energy increases, so does the likelihood that it'll just pass right through the body. So a super strong X-ray is more likely to just pass straight through and get to the IR than it is to remain in the body or create a whole lot of contrast. X-rays with high penetrability are referred to as high quality, and those with lower energies or penetrability are low quality. Now, no matter what, at any given energy, high or low, X-rays are more penetrating in tissues with low atomic number, like lungs that have those really small hydrogen or oxygen atoms, than tissues with high atomic number, like bone, which has calcium atoms in there. So no matter what, with energy, we usually get black where air is, and a little bit brighter absorption where bone is. Finally, attenuation is a term that refers to the overall reduction in X-ray intensity that we just talked about here, all the different kinds of intensity, that results from either absorption, again in things like bone, and scattering, where we get that Compton interaction.